Well, hello and welcome back. It is time once again to try to fix something. And today on the workbench, we're looking at another dead PS5. I didn't notice what model this was. We'll check it later though. But it's supposed to be no power, totally dead. And let's just see right now if that's the case. Yes, I do have power connected back there. Totally dead. All right, well that's a good step forward, as it actually is as described, as it was described to me. So let's get some covers off. Let's see if she's been worked on before. And the plastic side plate is off. And yes, I'm going to say she has been worked on before. Missing this cover, missing some screw. A screw here, there. I'm not sure what else. Those are in there. So yeah, she's been taken apart before. Okay, and this is obviously either a 1015 or 1115 because of that cover. Let's just see which one is it. Can we tell? Can we read it? 1115A. All right. Let me see if I can get some more covers off. All right, we are a little bit further in. And I need to check for 12 volts on this 4-pin supply. And it does look like there has been some roach activity on this board in the past. So that's always nice. Right there. Yes, we have 12 volts. So it's not a dead power supply. Is it, after seeing this stuff, I'm wondering if the problem is going to be corroded capacitors. Shorting something out on the back side of this area right here, right behind the Wi-Fi module. That's what I'm wondering about. Well, here we are inside the workbench, and I was looking around the board around this. This is, of course, that area around I was talking about earlier, behind the Wi-Fi module, where I suspected one of those caps might be corroded and shorted. I don't see any of them that look all that bad. Just with the eye, nothing looks, totally corroded away. There are signs, or there is signs of, some roach activity, but it doesn't seem to be as bad as I thought it was. So let's just see how much current this board draws. I always find that helpful. If I can get these leads connected. Make sure my supply is set up over here. Yeah, I've got it set for 12 volts, half an amp. Let's just see what she does. Oh, that's really dead. 3 milliamps. Okay. Almost like I'm not connected, but I believe I am. So we don't have a dead short on the 12 volt line, that's for sure. But, So we're missing something. What's it going to be? Shorted cap. Blown fuse, and that's acting like there's no 5 volts is what that's acting like. All right, let's get the meter out. Just see if we can figure something out. Get that reflection out of there. Some continuity mode, maybe. Let's see. 5 volt short? No. Not a 5 volt short. I have a blown fuse over here going into the standby supply. Yep, fuse is open. F7003 has opened. Right there. Okay. I wonder why it opened. Most likely suspect would be a short around this DA9065 or RT5126, whichever one it is. I believe it is the Rich Tech. Yeah, 5126. I think that's right. Do we have a short there on the input side of the fuse? Yes, we do. We do indeed. So that makes sense then. Now in the past I've had this. This IC just seems to rarely fail. I'm sure it can, but what usually happens is one of these filter caps, you know, either here or over here, or there's several around here. I think there's some on the back side of the board. That's what usually fails. Let me see if I can get my microscope turned on, and let's just see if we can find this quickly. Doesn't look like I was quite prepared. I don't even have my microscope turned on. I really thought it'd be one of those corroded capacitors. Not today. All right, let's look around this IC if I can find it. There it is. Nope, not that one. There it is. Just wonder if any of these capacitors are going to look, you know, really, really obvious. Have a crack in it. None of them look terribly obvious. Okay. Let's take a quick glance at the other side of the board, right behind this IC. Any of these look suspect? Not that I can tell. No. I'm pretty sure. Let me get that back in focus. I'm still in continuity mode. Let's see. Short there. Not there. Now short on that one. Not on that one. Not on that one. Of course, down here. I wonder if this could be a, yeah, short there too. This is another DC-DC converter. I believe this makes 2 volts, 1.99 or something. That does connect to that RT5126. So we need to inject. There's just a lot of stuff going on. There are several capacitors across 5 volts there, and any of them could be our suspect. Let me get set up to inject some voltage and see if we can find something getting hot. Alright, well, I have soldered a wire on the 5 volt rail going into that IC. A healthy wire that should be able to supply us some current. And I'm using my second channel of my power supply set for 1 volt, 3.2 amps. And I have a thermal camera ready to go over here. So, let's see. Let me enable it. Let's just see how much current we draw. Ooh, the full 3 amps. Okay. Let me leave that off a second. Let me get my thermal camera. Get it at the ready here. Okay. Let's just see. Where? Oh, getting pretty hot where I'm injecting right there, isn't it? See that? I believe that's the capacitor directly below where I'm connected. Because you can see this right here is the wire that I've got soldered to the board. And what's getting hot is directly underneath it. I don't think it's the IC. Don't think it is. If I get any closer, it's just going to get blurry. Okay. Let me see if I can we switch to the microscope maybe? Just to kind of further narrow that down. Just a second. See if I can get set up to do that. Maybe we'll put a little alcohol on there and see what happens. Okay. Let's get Yeah. So it looks to be that capacitor right there. But, you know, hard to be absolute. Let me get some alcohol ready on a cotton swab. Just see if we can narrow it down. There's the chip. No, chip stays cold, I believe. You can see it's heating up the edge of the chip, though. I think it's going to be that capacitor right there, which has a scratch on top, but I think I did that with the probe. Yep. I'm going to say it's that capacitor right there. Still drawing 3.2 amps at 0.319 volts. It's a pretty good short. Okay, I've seen enough. I think that capacitor needs to go. Go ahead and take our wire off. Try to clean up some of that solder. I sure don't see any marks on this capacitor that would make me think that it was bad. But it sure acts like it. Alright, now maybe a little... It's already got flux in there where I was attaching that wire. Let me add a little leaded solder to those end caps to help maybe help us remove it. Like so. Maybe get a little hot air going. Alrighty. This is max airflow at 450C. So she should come off pretty quick. So you can see it's hooked to some pretty good sized pads. Large traces. There we are. Okay, now I am just curious if our short is gone now. Back to continuity mode. No short. No short. Excellent. Where's that capacitor? Right there. Oops. Come back. I wasn't through torturing you. Yep. Very shorted. Looking to see if we could see a mark on it. A split or something? No, not really. Oh wow, but she's definitely bad. Put that to the side. Alright, we need a fuse. We need a fuse. This one is done for. Let's see if I can find a fuse. That one is the one marked with a T symbol, which I believe is a 5 amp fuse. I'm going to confirm that. believe that is a 5 amp fuse. All right, let me find a fuse. I know I have some. I could pull one from a donor, but I know I bought some. Finally. All right, found my fuses. Let's get that off of there. Let's add a little leaded solder. Go ahead and take my other fuse out of the pack so I've got it ready to go. Hopefully I don't lose it. That fuse is down. I always like to hit the end caps on it there just to make it look a little more presentable. You know what I mean? All right. Clean it up a little. Oh, we need a capacitor, don't we? Almost forgot. We do need a capacitor. I don't know the value of that one. Let me find a donor. Let's see, it's at least 10 microfarad, maybe 20. Looking at the size of it. Okay. I found a donor right here. Right there. Looks like I've already stolen the fuse off this one. I don't think I have any new of this capacitor. Should probably get some on hand. See if we can get this off. Maybe we'll measure it while we're in here. came off pretty well. Again, right there a second. It will let go of my tweezers. Alright. There's our donor cap. It's a little toasty at the moment. And while I'm thinking about it, I'm going to try to measure it. Let me get some of this flux off of it. Oops, where'd it go? So that I can get better contact on the end of it there. Alright, let me see what I can measure here. I need it not to go flying. It went flying. Come back. What I should have done was just flipped it around on the board and left it attached at one end and then measured it, but I wasn't thinking. Haven't gotten a good reading on this thing yet. I'm using my smart tweezers. .8 microfarad. Okay, so basically I think it's a 20 microfarad. I can change the frequency that this uses, and it will, you know, affect. You can see it there. You can set the frequency that it uses for testing, except for 100 hertz. Now I was using 1 kilohertz. What does it show at 100 hertz? Since this is a relatively larger, you know, value cap. No, don't do it. $20 microfarad, 21 microfarad. 21 microfarad. Okay, so it's basically a 22 mic cap, and it's across a 5-volt rail. So I'm not sure if you'll be able to see it if I measure it with, you know, on the overhead camera. I'm going to lose this capacitor yet. .17 it says there. Okay, so 22 microfarad. Let's get this installed. A little flux there. All right. All right, what do you think? Is it going to work? Let's find out. Let's find out. Let's see. Get this out of the way. I need my other channel of my supply. This one. I was using the right channel of that supply to inject 1 volt. Okay. Now what? Let's see. So set for 12 volts, half an amp. What's going to happen? 300 milliamps and come back down. Ladies and gentlemen, I think we have a working board. All right. Let me clean up some of the roach remnants and we'll test this board out there in the chassis, see what happens. We are back out of the garage and I think we're ready to test this. I've got it assembled just enough. Yeah, power is connected, fan is connected, monitor is connected. Let's see what happens. Blue light, fan spin. Are we going to get something on the monitor? Not yet. Flashing blue. Nothing yet. I didn't look at that HDMI port. Oh, it locked in. There we are. Much better, much better. All right, I think this thing's going to work. I need to do a little more cleanup on it. I need to clean that fan and, you know, I just basically just blow the dust out really well. This one's not that bad, even though it does have a little signs of a roach activity. Not a lot. If it was a bad roach activity, I would have it all in pieces in the bathtub scrubbing it. But it's not that bad. Just some dust and a little bit of mess. All right, there you go. Let me get this put all back together and we'll give it a thorough test out. How's that sound? Well, this PS5 is fully reassembled and has been cleaned up a little and is looking pretty good. Even included a free PS5 game in the drive, so that was a bonus. But she's all back together and I think she's going to be just fine. Well, hope you liked that. Thought it was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up and I will see you in that very next repair. So long for now.